travel. So at that point, once you've got the servo horns to 90 degrees to the bell crank and set up the links to match. So once you get that perfect, then obviously you just set up these linkages for no binding. You adjust the lengths, a couple of turns one way or the other to get them to go on with no binding, so that they are the correct length. And then from there, once you do that, then you what I did is I simply popped the head off. Popped everything on the head off except for the swash plate. Put my 600 size swash plate leveling tool on there, which looks like that. It slides down over the head, sits on the 3 points on the swash, and then you can see any gaps underneath the swash where it's not level. And then, of course, from that point, you adjust your three. If it's not level at mid stick, then you adjust the. You don't adjust sub trim at this stage. You adjust these links here, either up or down, for a perfectly level swash where all 3 points are touching. And then what I do from there is I go to full high stick and let that ride up. And if it's out, then you simply use your end point adjustment or travel adjust on that particular servo, whichever one is off, to bring it up to where it's level. Do the same, go all the way to low stick, use your travel adjustment on that point to make sure that your swash is level at the very bottom stick. So now we've leveled the swash at mid stick, at high stick, and low stick, and with ECCPM, that's if you've got any interaction, meaning that between mid and high and between mid and low, if the swash does not stay level, then you can of course put programmable mixes in to mix that out. But with modern radios, I find that that's not necessary. That if you level it at mid stick, at high stick, and low stick, they tend to stay level right throughout the whole travel. In your JR radios, in your swash mixing for your CCPM, turn your Expo on, and it helps to remove that interaction. It helps to electronically compensate for the different speed that the elevator servo rises in relation to your pitch and your aileron servos. But in any case, so once that's done, once the servos are set up, your 90, and once your swash is leveled throughout its range of travel, then you put the head back on, you put your washout base on, you put your phasing ring on, you put your head on, you bolt it all together. And at that point, you can then set your phasing. That's the next step that you really should do. Now, basically, the reason why we set the phasing at this point is because now we've finished taking the head on and off, and so now we can set the phasing. So what you do is you line up, and the way that you set the phasing, and you'll see this in the manual, is that you line up the washout mixing arms with the grips, and so that they are in a perfectly straight line. And it makes it really easy because the head block has got a square side to it up at the top, that if you look straight down on that square side and you line it up with your washout arms, they fall right in line, and you can basically sight straight down the square side of the head block and line it up with your washout arms, and bang, that's your phasing all set. And then what you do is you put that phasing ring, you slide it all the way up until it hits the head block to give you as much room as possible for the swash to travel up and down before it hits the phasing ring. And on the phasing ring, it's got two set screws. They originally came with the set screws both on one side of the phasing ring. I prefer one set screw on one side, one screw on the other side, so I removed one, put Loctite on them, put the opposing screws in, tightened them down, making sure that the phasing stayed lined up square, and that set the phasing. Once I had done that, so now I've completed the basic electronic setup at this point, set the phasing, set the head up. Now at this point, what I need to do is I need to check, put the blades, so then I put the blades on. And then what I did is I checked at mid-stick. I put the heli back at mid-stick, and I made sure that we were at 0 degrees pitch. This is for a 3D setup, of course. I made sure that the main blades were 0 degrees at mid-stick, and just adjust those main blade grip links if they need adjustment. Mine needed just a couple of turns of adjustment on both sides, making sure that the links stay equal length. Made them both 0 degrees, and then I went to high stick, measured the pitch, went to low stick, measured the pitch. If at that point, and mine was out just a little bit, so I had a little bit more positive than negative pitch, and you want them to be symmetrical on the top and the bottom. The links that you adjust to make them symmetrical, if they're not the same positive and negative pitch, there's a few ways to do it, but the easiest way that I've found to even those up is with these long links that go from the flybar carrier mixing arms right down to the swash. So you adjust those, making sure to keep them the same length. You adjust both sides the same. You either decrease or increase the length of those two links to even out your pitch. So if you start out with plus 11 and minus 9, you want to even that out. So adjust those links as required, either in or out. It'll take a bit of trial and error to get it exactly right. But then you even that pitch out, and then when you've got the pitch being equal, say plus 10, minus 10, or whatever the case may be, you can go into your swash mixing menu if you want more overall pitch, and you can just increase the pitch value in your swash mix menu. So once I did that and evened that out, I set it for about plus 12, minus 12 worth of collective pitch. It's all nice and even. And then I proceeded to measure the cyclic pitch. And the way that you measure your cyclic pitch is exactly the same way that you measure your collective pitch, which is using a pitch gauge on the end of the blades, except for you're measuring the aileron and elevator. So what happens is, if you want to measure your elevator pitch, you put the fly bar in line with the boom, and then you put the blades out like you would with measuring main blade pitch, collective pitch, sorry. And then what you do is you put the collective pitch at mid stick, so at 50%. And then what you do is you put in only an elevator input, and then you measure the blade pitch. And then if you want to measure aileron cyclic pitch, and you measure both directions. If you want to measure aileron, you turn the blades around, turn the head around to where the fly bar is perpendicular to the boom, and then you put in a pure aileron input, and at that point you measure the main blade pitch, and that will tell you how much aileron pitch you've got, and you want to match them. You want to match your aileron and your elevator out of the box. I set them both for 8 degrees. That's a reasonable amount of cyclic pitch, especially on a Compass helicopter. They tend to be very lively in the cyclic, so I may wind that back at a later date. And you can also, once you're at the field and you're flying the helicopter, if you find that it does not flip or roll at the same speed, then of course you can speed up or slow down by increasing your overall cyclic throw, the travel, to match them. But on the bench, I always match my cyclic so that my aileron and my elevator cyclic are identical off the boards, and it always flies really, really well. You may have a slight speed differential in flips and rolls, which you can adjust at the field, but off the bench, I find that matching them makes the best setup possible. At least you know what you're going to get. It's a predictable flying helicopter. I could easily, with this new head design on the 3D Plus, I could easily have gotten what appeared to be about 15 degrees of positive and negative, plus about 8 degrees of cyclic, so more pitch than just about anybody would need. So anyways, that's my that's probably the final I think the final phase of the build process. I have test hovered this in the front garden, and it worked perfectly fine. There were no untoward issues. Blade tracking was bang on. No surprises there. So once I get a chance to wring it out a bit more, I'll try to get a flight video, and I'll put my contact details on the end of this video, so that if anybody needs to email me or ask me any questions, hopefully I'll be able to help you out. So I hope that this build video has assisted you in the build of the Compass 3D Plus. In closing, I have to say it's a well-built helicopter. It's a well-designed helicopter. It's the best 50-size nitro from Compass so far, in my opinion. And yeah, I really think you're going to enjoy the helicopter a lot. It's got the typical signs of Compass durability written all over it, like all Compass models do. Really durable. They all fly very, very true and accurate. You know, they fly like they're on rails, to quote someone else. And they're just a very predictable, nice flying helicopter that has some outstanding 3D capability, and it's just a really well-built helicopter, and it was a joy to build, and hopefully you get as much fun out of it and joy out of it as I did. And we'll speak to you soon. Thank you.